So here we have another polynomial function to try to graph. So we have to first generate our P over Q list. So recall that our numerator, our factors of P, are the factors of the last coefficient, and our Q values the factors of the first. So since that's a 1, we really just need the factors of that last number, since everything's going to be divided by 1. So we're going to have -3 is the biggest negative that we can get. -1, 1, and 3. So we have a pretty short list here. So let's see how that goes. So we've got to use some synthetic division to find a 0, but that's the only 0. We're only going to have to find one 0 on this one using synthetic division, because then we'll knock it down from a cubic to a quadratic, which means we'll then be able to factor. So if we get started here, we can pick a number from our list. So let's try 1. So my coefficients on the inside are 1, 1, -5, and 3. No terms missing, so I just go in order of the coefficients I see. So we start rolling through it. So I got a 1 here. 1 times 1 is 1. Add that together to get 2. 1 times 2 is 2. -5 plus 2 is -3, and we've won the lottery again. 1 times -3 is -3. We get 0. So we have indeed found that 1 is a 0 of this polynomial function. So I know my graph is going to go through 1 on the x-axis. So I have a column, so zeros over there. So we need to find the other two zeros, so that's where we go with this. Recall that this was the coefficient in front of x cubed, so in my answer, this is the coefficient in front of x squared, and then we go downhill from there. So I've got x squared plus 2x minus 3 equals 0. So I need to try to factor that. So I'm going to break it up into a couple of sets of parentheses. I've got x and x. I know I need one positive and one negative because I'm multiplying to make that -3. And the only factor pair for 3 is 1 and 3. So I need a +3 and a -1. So if I take each of these and set them equal to 0, and then I subtract 3 from both sides, add 1 to both sides, I get my remaining two zeros. So I can see that I'm getting -3 as well as +1. So in this case, we've got that 1 showing up a second time, so we have a repeat 0 in this case, and then we also have that -3. So with that repeat 0 at 1, that means our graph is going to bounce off of the x-axis at that location instead of passing through it. And then with the x equals -3, we can go ahead and plot that point as well. And so now we're ready to move on to our leading coefficient test and little point plotting to figure out the rest of the graph. So the leading coefficient test, we're going to look at that highest exponent piece. So it's odd. So according to our leading coefficient test, we're going to have a disco graph. So we're going to be up on one side and down on the other. And with a positive coefficient, if I plug in a positive number in for x, I'm going to get a positive number as a result. So that means after I'm done crossing through the x-axis the last time, I'm going to be up on the right, which means I'm going to have to be down on the left. So the last time that we're making contact with the x-axis is here at 1. So that means I'm going to be bouncing off of that location and going up. So then from there it's going to bounce, it's going to go back up. Now I can see that my y-intercept is going to be 3, so I can kind of store that away. I'm not going to quite plot that yet in case I need to account by something other than 1s in the x direction. But if we wanted to figure out what that local maximum between -3 and 1 is, I'm going to pick the number that's halfway in between, so that's going to be -1. And so once again, I can either just plug that in for x everywhere, or I can do it via some synthetic division. So if I go -1 on the outside here, and then we've got 1, 1, -5, and 3, I have to go back to my original function. And if I roll through my synthetic division, I've got 1, -1, 1 and 1 is 0, -1 times 0 is 0, add that and get -5, -1 times -5 is 5, 5 and 3 is 8. So I get a remainder of 8. So that means my graph is going to top out at -1, 8. That might not be the exact local maximum, but it's a good estimate. So I don't need to rescale my graph this time. I know I'm going to go through 3 on the x-axis because of the last number there is our y-intercept. I go through -1, 8. So we're going to assume we top out right about there. So our graph is going to go up, and then it's going to come back down. And then because we've established this is a disco graph, and we are crossing through the x-axis that last time, so the graph is going to be going down from there. So we've got the sketch of our graph.